Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 4. Hello there. Designing a search robot to find a beacon. Okay, so we're going to design a robot in this lesson. How cool. Classwork opening exercise. Write the equation of the line that satisfies the following conditions. So this is a review from algebra. A line has a slope of m equals -1/4 and going through the point 0, -5. Okay, so we have the equation y equals mx plus b. M is the slope, the change in y over change in x, and b is the y intercept, which means the y value when x is 0. So we have all the information we need right here. So when x is 0, this is our b. So we have our m and we have our b. We just substitute it in here. So it's y equals m -1/4 x plus b. Well, plus a -5 is just simply -5. So the equation of a line of a slope of a -1/4 passing through the point 0, -5 is y equals -1/4 x minus 5. But now we have one. They didn't give us the slope and they didn't give us any 0, something. So we don't see b here. So these are 2 points. So we're going to use the point slope formula for this. So the point slope formula is y minus y1 equals m times the quantity x minus x1. Okay, so I'm going to name this x1, y1, and this x2, y2. The x from the first point, the y from the first point, the x from the second point, the y from the second point, and that's where that comes from. Well, slope is y2 minus y1, so slope equals y2 minus y1 over x2 minus x1. So then I just substitute in y2 minus y1 over x2 -2 minus 1. So that's going to give me -1 minus 3 is -4. And -2 minus 1 is -3, and a negative divided by a negative is a positive. So I get 4/3. So there's my m. Then what I do is I substitute in one of these 2 points. I prefer to deal with positive values. And so in that case, if I put negatives in, a minus and negative becomes plus. So you can use either one of these points, it doesn't matter. So I'm going to write y equals, and since it says y1 and x1, I'll put those in. So y not equals y minus y1 equals m times x minus x1, which is 1. So we have y minus 3, then we distribute. Yes, we distribute this from here to here and here. So that is going to be y minus 3 equals 4/3 x minus 4/3 times a -1 is 4/3. Okay, so I'm going to continue up here. And a minus 3, so 3 is equal to some fraction with a denominator of 3. Well, it's 9. 9 divided by 3 is 3. So I'm changing this to 9/3. Y minus 9 over 3 equals 4/3 x minus 4/3. So I'm going to add 9/3 to both sides. And that will give me y equals 4/3 x plus 5/3. Okay, so that is the equation of the line passing through these 2 points. And we can always check if I plug in 3 here, I should get 1. So if I plug in a 3 here, the 3's cancel, I get 4 plus 5/3. I'm sorry, plug in x for 1. 4/3 plus 5/3 is 9/3, and 9/3 is 3. Plug in a -2. That would be -8/3 plus 5/3, which would be -3/3, and -3/3 is -1. So these both check. So this is the equation going through these 2 points. Slope of 4/3, y-intercept 5/3, or 1 2/3. Okay. Okay, now we have an exploratory challenge. A search robot is sweeping through a flat plane in search of the homing beacon that is emitting a signal. A homing beacon is a tracking device that sends out signals to identify a location. Programmers have set up a coordinate system so that their location is the origin. The positive x-axis is the direction to the east. The positive y-axis is the direction of north. The robot is currently 600 units south of the programmer's location and is moving in approximate northeast direction along the line y = 3x - 600. Along this line, the robot hears the loudest ping at the point 400, 600. It detects this ping coming from approximately a southeast direction. The programmers have the robot return to the point 400, 600. What is the equation of the path the robot should take from here to reach the beacon? Begin by sketching the location of the programmers and the path traveled by the robot on graph paper, then shade the general direction the ping is coming from. Okay, so I brought in this graph. Okay, and looked at these values. We want them in our printable area, if you will, our grid area. So let's take a look at this again. The robot is currently 600 units south of the programmer's location. Okay, so 600 units south of the programmer's location. The programmer, I believe they said, was at the origin. And let me see to make sure. Yes, the programmers have set up the coordinate system so that their location is the origin. Okay, so the programmer is here at 0, 0. The robot is currently 600 units south of the programmer, so that's a y-intercept of -600. That's right there. So that's where the robot currently is. And it is moving in an approximate northeast direction along the line of y = 3x - 600. So if I have that equation, y = 3x - 600, and I want to know when y is 0, what would x have to be? So in other words, I want to find where it's crossing the x-axis to make this an accurate drawing. So the y-axis, so y would be 0 when we're on the x-axis. So that would be equal to 3x - 600. And to solve this, I add 600 over to the other side and get this, and then divide by 3 and get x = 200. So I would be right here. So that is our equation of the line, and that's how we graph it. And I'll make it a blue line. So we're going from 0, -600, and going in this direction up through 0, 200, like so. So there is the line with a slope of 3 with a y-intercept of -600. Okay, and let me just put an arrow here, there, because it's going forever. All right, so that's that. So now it says along this line, the robot heads to the loudest ping at the point 400, 600. So if I go 400, 600, the loudest ping was right there. It detects the ping coming from approximately a southeast direction. So southeast is over here somewhere. The programmers have the robot return to the point 400, 600. What is the equation of the path the robot should take from here to reach the beacon? Begin by sketching the location, the programmer, and the path traveled by the robot on graph paper, then shade the general direction the ping is coming from. Okay. So this would be due east, and it is southeast. So, okay, so it says to begin this by sketching the location, the programmers, and path traveled by the robot on the graph paper. Okay, So there's this, the programmers are at the origin. The robot started at 0, -600 and went on the path of y equals 3x minus 600 and found the loudest ping to be at 400, 600. And they realized that it was southeast of there, which is this way. So if I drew another line through this point, perpendicular, like so, and I'll extend it. Like this. Okay. And it says to shade the region. So if I choose a rectangle, rotate it so it's parallel to the blue on one side, then I would say that the direction, it can't be exact, so I'd say the direction be somewhere in this vicinity. We don't want to go up here per se, but somewhere down around here. So if I were to just shade this, like so. So somewhere in this shaded region over here. So there is our graph. There's our sketch. But it asked us what is the equation of the path the robot should take from here to reach the beacon. So if we are at the point 400, 600, and the slope of this blue line was 3, the slope is 3, then a perpendicular line, when you have a perpendicular line, the slope of a perpendicular is negative 1 over the slope. So it's a reciprocal, negative reciprocal of the slope. So if the slope was 3, then a perpendicular slope would be flipped negative 1/3. So my equation would be y equals negative 1/3 x plus some b. So I could use this point here and another point somewhere to do the equation like we did up in part B up here. But the reason I extended this purple line up to here was that it gave me an approximation of the y-intercept, and the y-intercept looks like to be about 750. So that is my B. So y equals negative 1/3 x plus 750 should be the equation of the path that this robot travels to search for the ping of the beacon. Alrighty. Okay, page 2 gives us an area to do the notes. Basically, I just extended this page right here. So under notes, you should have a graph in your work to figure out what we just did. So I'm going to skip that notes part. I'm going to go down to this example and let me extend the page and clean this up. Okay, that's better. So it says the line segment connecting the point 37 to 10,1 is rotated clockwise 90 degrees around a point at 3,7. Plot the segment. B, where will the rotated endpoint land? And C, now rotate the original segment 90 degrees counterclockwise before using a sketch. Predict the coordinates of the rotated endpoint using what you know about the perpendicular slope of the rotated segment. All righty, so I'm going to need to plot some things here. So let me bring in a graph. Okay, so I brought in this graph. Let me get my ruler. I'll use a ruler to do this. So it says plot the segment. So the line segment goes from 3, 7. So here's 3, here's 7. So it goes from here to 10, 1. So here's 10, here's 1, right there. So I want to draw a segment from 3, 7 down to 10, 1. Just trying to be really accurate here. And I don't know, red. So I'm going from 3, 7 down to 10, 1, just like that. So there's the segment. So A, plot the segment. Check. All right, so the line segment connecting the line segment connecting the point 3, 7 to 10, 1 is rotated clockwise. So this way, 90 degrees, about the point 3, 7. So I need a point at 3, 7. So 3, 7, it's rotating it around its endpoint right here. Where will the rotated endpoint land? So if it is 90 degrees, it's going to form a 90-degree angle. Okay, and so I need to find the slope of this line. All right, so slope equals y2 minus y1 divided by x2 minus x1. So that will give me a -6 over 7. That's the slope of this line. It's -6/7. It went down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, 6, 7. Can't be reduced. There's the slope. The slope of the perpendicular would be the negative reciprocal, so it would be a +7 sixths. +7/6. So in other words, I would go up 7, right 6, or down 7, left 6, and that's what I will do. So I'll go down 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4, 5, 6. So it's going to end up right here. So if I draw a segment from there, then I'll get, I will get my ruler. Why is that? Oh, I know why. I'll get my ruler and rotate it and draw a segment from -3, 0 up to that point 3, 7. And I'll use a dash line this time. And let's make it red. Okay, so there is a 90-degree angle. These should be the same length. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So if we did two triangles, they'd have the side lengths of 6 and 7. So therefore, the hypotenuse on both of these triangles that we would form with these sides would be equal. It'd be the sum of 6 squared plus 7 squared and taking the square root. So these are the same length, and that's where the rotation would end up. Okay, so part B says, where will the rotated endpoint land? So where did this point, that's right here, which is at the point, oh, how cool. Which is at the point, let's make it solid, which is at the point 10, 1. It ended up at -3, 0. So when I rotated it, it ended up being -3, 0. Okay, so that's B. And then C says, now rotate the original segment 90 degrees counterclockwise. So the original is here. They want us to rotate it this way now, up here. Well, it's going to be a straight line of the same length ending up somewhere up here. So it says, before using a sketch, predict the coordinates of the rotated endpoint using what you know about the perpendicular slope of the rotated segment. So I know it's going to be an extension of this line going up. So since this is going up 7 over 6, I'd go up 7 more over 6, which would be 14, 9. So it should end up at the point 14, 9. So if I were to extend that with my ruler, which I'll just do like this. And I'll make it green this time with a dash. Then it's going to go up somewhere like so, but it's not going to be that long. It's going to get over to 14, 9. Is that what I said? Or do I have it backwards? Yeah, I have it backwards. It's 9, 14. All right, so go over 9 up 14 would be about right here. I'm off my graph, so it's 9, 14, and I need to shorten that. So then I move this, shorten that segment down to here. Okay. And so this red dashed line should be the same length as this green dashed line, and it's the same length as this red solid line. And my rotation would be 9, 14. Okay, page 3 brings us to an exercise. So pause the video, see if you can do parts A through D, and then unpause and come back and see how you did. All right, so here we go. Exercise. The point AB, located here in the first quadrant, is labeled right there below. A, using A and B, describe the location of that point AB after a 90 degrees counterclockwise. And remember, counterclockwise, whoops, what just happened? Counterclockwise is this way. Okay, about the origin. Draw a rough sketch to justify your answer. So what you could do, I'm going to use electronics here, of course, but you could use a ruler and draw. I'm just going to write or draw a segment from the origin up to AB, like that. Well, what does that form? Well, it forms a right triangle. So now if I draw a segment out on the x-axis, or in this case, the a-axis, and then up to the b-axis, up the b-axis, or up direction positive b, instead of xy, we're using ab. You just move this up a smidge. Okay, there it is. It forms a 90 degree or right triangle. So if I take each one of these, shift, let's see, choose this side and that. And I'm going to group these. Okay, so then if I rotate these 90 degrees counterclockwise, it's going to look like this, but it's rotated about the origin, which means it's going to put this right here, like so. Oops, Control Z. Okay, so I want to make a copy of that and leave it. Whoops, I don't want to change its size. I want to put it back to where it was. So here was the original. Okay, like so. Rotating it 90 degrees this direction puts it here. So now the point is this distance right here is a distance of A. We went to the right a distance of, I'm sorry, I'm doing this backwards. A is our X, B is our Y, A is our horizontal. This is a distance A here, and this is a distance B. So to the right is positive, and up is positive. So A and B are both positive here. So this would be my A prime, if you will. So that's positive, but we're going left here. So my B prime equals a negative B. That's a distance from the origin, left a distance of B. And this was up a positive A. So the point that's right here now would be the point negative B, comma, A. So we went left a distance of b, which is negative b, and then we went up, which is positive a. So the point negative ba. So draw a rough sketch and just to justify your answer, describe the location. Well, the location is the point negative b, comma, a. Okay. Okay, now part B says, if the rotation was clockwise about the origin, what is the rotated location of the point AB here? In terms of AB, draw a rough sketch to justify your answer. So I'm going to copy this again, and I'll plop it right down on top of its original. So now we're going to rotate this clockwise 90 degrees. About the origin would put it right here. So now the point we're talking about is this point right here. And so we went to the right a distance of B. This is my B down here now. So this is B. Let me move it up inside so it's not over those words. That's the distance B right here to the right. So it's a distance from the origin to the right, a positive B, but then it's down a distance of A. So my new location would be over B, down A, B, comma, negative A. Okay. Part C says, what is the slope of the line through the origin and AB? So remember, slope equals y2 minus y1 divided by x2 minus x1. And my y2, so this would be my point 1, the origin, and this would be my point 2. So this is point 2. And the origin here is point 1. So my y2 is b minus my y1, which is 0, over my x2, which is a, minus my x1, which is 0, because it's 0.00. So b minus 0 and a minus 0 is just b over a. So the slope of the line through this point right here, the slope of this line right here would be m equals b over a. In other words, I went up b over a. Okay. D says, oh wait, I'm sorry. What is the slope of the perpendicular line through the origin? So the perpendicular line through the origin would be this slope. It's negative. It's going down from left to right. So remember the reciprocal, the slope of the perpendicular equals the negative reciprocal of this. So the slope of this line would be negative a over b. Okay, so the slope of this, we're going down a distance of a over a distance of b, down a distance of a over a distance of b. So there it is. D, what do you notice about the relationship between the slope of the line through the origin and AB and the slope of the perpendicular line? Well, they're negative reciprocals. Okay, so we'd say the slopes are negative reciprocals of each other. Their product is -1. So what they mean by that is the product of the two slopes of perpendicular lines, their product, if you multiply the slopes of the two, you get -1. So if I took b over a, which is the slope of this line, and multiply it by the slope of this line, which would be negative a over b. Well, the b's cancel, the a's cancel, and when we say cancel, negative a over a is just -1, and b over b is 1, so it'd be -1 over 1, or simply -1. All righty. Okay, page 4 brings us to the end of lesson 4. Go to your problem set.